Hello world and welcome back to another video. In this video I wanted to go ahead and explore the Elrond dApp template that they used for the Ping-Pong app. Basically it's the tutorial that we followed in previous videos that we covered here, and I'll post the link in the upper right hand corner somewhere around here. And basically we followed that and just kind of explored how to interact with the Ping-Pong Smart Contract and the dApp. In this video, we're going to also dive a little bit deeper into the code of the dApp for the React.js code there, and manipulating it so that way we can pretty much interact with the Multisig Smart Contract wallet, or smart contract that we created in the third installation video. I'll also post a link to that right up here in the corner here too, in the description as well. So without further ado, let's go ahead and get started. So I'm going to go ahead and open up a new Visual Studio Code window here. And I'm going to open a folder, and let's navigate our way to this folder that I created here. Excellent. Now what I'm going to do is I'm also going to copy some of the wallets we've been using in our past videos too, so we're using the same user here. So is this with Adam? Looks like it. So I'm just going to copy this. And I'm just going to paste it inside here. Okay. See, let's double check. And that's our wallet. Looks good. Fabulous. So for this, I'm going to go ahead and try to quickly bring up the, and just make some notes here too, actually. Excellent. And then I'm just going to paste some of that side there. Fabulous. So what we're going to do first is we are going to actually set up the Elrond workspace. So let's just go ahead and do that with bash. So there we are. So it looks like it's gotten set up here. Looking good. Alrighty. So now what we're going to do is I'm going to control tilde. We are inside the Explore dApp. Okay. And copy this, and we're just going to clone the repository there. There's our contract, ping-pong. Excellent. Okay. So let's see. Change directory into there. And we're going to build a contract. We're pretty much just running through the runbook here on the examples that the Elrond docs website gives us. So And while this gets set up, I'm going to navigate to our ERD Pi JSON file, and I'm going to just update it basically with the wallet location right there. I'm going to not edit anything here like we did in the other video, but just keep the basic configs set just to show the example that I'm trying to show you and how we can observe how this smart contract and dApp interact with each other and find the locations of where we can manipulate it to interact with a different type of smart contract. In this video, we're going to try and use the Multisig Smart Contract wallet. So let's go ahead and take a look. We got ERD Pi right here. Just going to go ahead and paste that in to update it. So we have our new wallet location, which should be right here. Save that. Fantastic. So now that we're all good to go, let's try and deploy it. Fingers crossed, everything works out. Okay, so like this is our contract address. So we'll just save that there. Okay. You can also verify this by going to the Explorer and taking a look to see if our address, and there it is, looks good, freshly deployed. That's my wallet and smart contract address. So far, so good. Excellent. So the next thing we're going to do is I'm going to go back to directories here. Okay, that looks good. And I'm going to run the get clone to download the dApp. Okay, that looks good. Now we navigate to the config file. And we're just going to update it with this smart contract here. Okay, save that. Alright, excellent. So, now that we have configured our dApp, or compiled and deployed the smart contract with all the variables, you notice that on time of deployment, we made the argument to send this many EGLD. And you know what? This is actually a little bit too long for this video. I'm going to make it 15 seconds. So let's go ahead and deploy this one more time. Okay. Alright, that looks good. Let's just copy this and we'll update that one more time. Okay, excellent. Alrighty. So now that we updated the config file here, one thing is taking the time to kind of look at the architecture and the way that everything is built out and the order that it is with directories, parent directories, subdirectories, things like that. In particular is this pages, dashboard, action, and index. When we open that up, you can see how it's importing for React, grabbing a bunch of Elrond stuff from the Node repository, Node.js, and you can also see some React fonts that they use here, right? And then, yeah, pretty much, if we analyze this dApp wrapper, we can start to deconstruct it and reverse engineer to see how it works. So in particular, if we scroll down, asterisk there. We can see that we get to around lines 85 or so, and we can start seeing how we have this ping here. So if we analyze it, right, we can see that it is all being contained under this actions here. So we can see it pulling in some info. You can see it's testing some logic here. Get time to ping. Now if we actually open up the smart contract source code, so we got the WASM as well as the source of the smart contract itself. We kind of do we can close this for now and just kind of do a cross comparison here. And look at the index right here. We can see, okay, we got get time to Pong, and you can see that these endpoints and things on the smart contract we can interact with is in existence right here, and they're being called on the dApp here on this web page. Has ping. I think that, does that have anything here? Nope. Looks like it's just pretty much within the smart contract. Let's see. So we have this send ping transaction, ping. You can see that we have ping right there. Constant, see, and then send Pong transactions, and you have Pong right there, and of course that's right there as well. If you scan through, you can also see that they also have the on-click send ping transaction, so you can see all the interactions and the conditions. If it, if it has pinged, then it'll transform the button to Pong, and you can see all the different ways we can interact with it here, kind of helping us decipher it a little bit more. Let's see, so class of the button, so FA arrow, arrow up, is there any, and then arrow down, yeah. Alright, so send ping transaction, and I believe that's right here, and we see the logic, so it's kind of all connected. You start to see the relationships and how they are referencing one another and any logic that's built out here, and you can kind of start using that to decipher, right? So, let's go ahead and, so we're in the dApp, let's go into the dApp folder, okay? Okay, has the packages there, excellent. So, let's go ahead and install. So now it's setting up the React.js template, the dApp that we set up here, setting all this up. Alright, looks like it installed well. Let's go ahead and run it. risks. I'm sure if you were to spin this up and maybe go to a third-party provider like Get Certified or Let's Encrypt or something like that, I forgot which one it was, I think it's Let's Encrypt, they'll give you some free 3-month renewal for cert, so it's kind of cool. But give that a second, let it load. Alright, let's give this a go. Okay, there we are. Let's confirm, see here that EP74 is a contract address. So if I'm in my dApp source config EP74, so that looks good. Okay, so we'll go ahead and ping, right? And let's see if it indeed takes our 15 seconds. Now, notice here that these are all the variables that are being set when we clicked on that button, right? So if you recall, we clicked the up arrow button and there was a ping button, and this is the action. So the data, right, that's being passed through is right here. And you can see the amount, the value, which is right here. So you can kind of start to deduce, right, and gasoline and everything else. You can start to deduce what is going on here. The contract address is being referenced and pulled in, right, from the config file, which we set right here, right? So you start to see how the relationships are happening. So once we got the ping, looks good, let's just sign it. And notice we have ping, so the button changed the Pong. Great, 15 seconds look like it took, so we're on the right smart contract for sure. View it on the Explorer. There it is. And you can see all the data here. That's an okay. Looking good. Yeah. Let's see if you can see it's actually holding 1 EGLD. Okay, cool. Fantastic. Alright. Now, let's try and Pong it. Get our EGLD back. And notice the data here. So we have data is now Pong, so it's not ping, so it looks like it's triggering this right here. So you notice the value's nothing, and the Pong's there. Okay, so let's sign it. Alright, we got an error. Not enough gas. Alright, I think I remember this one. So, I think we have to add some stuff here to it. Let's see. Where did the Pong go? There it is. Alright. Save this, recompile, and let's try it again. Pong, alright. Alright, awesome. Cool, so you're starting to see how these the smart contracts interacting with the smart contract there. So let's kick this up a notch. I'm going to stop the server, okay, for now. And what we're going to do is, let's go ahead and deploy another Multisig Smart Contract, just like what we did in the other videos. You can use the same Multisig Smart Contract address that we did in the other videos if you still have it. Just for this one, I'm going to create another one from scratch, but it's pretty much using the same work that we did in those other videos here. So let me, ERD Pi contract deploy. Okay, looks good. I think this is the contract. So let's double check on the Explorer. Yep, and this looks like the multisig contract where we set up the multisig to be payable by smart contracts and individuals as well. But it's a freshly new contract, so we'll use this here. Okay. So we'll go down and update the config file to use the multisig address. Okay. And we're also, again, going to edit the same file. Okay, so now I go into my config, update that, so now we're using smart contract for the multisig wallet for this dApp. Now here's where the fun part becomes here. Now, if you recall in our last video, or in a multisig video, part 3 specifically, since that was the one where we did completely open smart contract for payable and whatnot, you'll notice that we had a number of different commands to execute. For example, paying that smart contract, we had to use the ERD Pi command, and notice how we're passing, notice all the variables, values, arguments, and things of that nature that we passed into it, right? Especially the data that we put in, right? So we're going to try and mimic these calls, but here's the catch. We're going to have to use that Elrond converter tool. That's going to be our friend here, because I, for right now, don't know how to put the, in the dApp, when we designed the dApp, I don't know how we're going to actually populate that inside here. But let's go ahead and take a look, and I'll show you what I mean. Okay, so from those run books, we're basically going to extract a couple of these calls that we're making to the smart contract, and inputting it with the data and the hex values of the data and arguments, like perform action and things of that nature. So what I like to do is I just like to make a backup of this here. Let's just copy this, paste it, and I just like to call it something like that. So now we're going to change this around. And using those commands, we kind of go through what we did, but in a different sense here. So let's go ahead and play around with this. So we're going to deposit some EGLD into that Multisig Smart Contract. So we'll save that. Still has our multisig. The CJX, yep. Index, we're going to send 6 and deposit it in to that. Well, actually, we don't need to open the door. We could just do it here. Okay. So let's go ahead and try to start up the app again. It takes a moment for it to fire up. Maybe I should just leave it on so we can get away with it. Okay. There we are, and you see the smart contract for the multisig right there. And this is going to deposit, and we should probably change that up too. So let's see, let's change this up. Instead of ping, let's just say deposit. So you can see it changed. Go ahead and do that. Explore that, yeah, looks good. Notice the data, that's looking great. It's the amount for 6. And we're sending it to the Multisig Smart Contract. Very cool. Let's see what happens. Alright, so it took our 6. Alright, let's take a look here. This is our smart contract for the multisig. And there it is. Excellent. Fantastic, so that worked. Fabulous. So what I'm going to do is rename this to 0.01. And whoops. Whoops. There we are. Okay, now this time, let us try to, let's see. Let us try to send another thing here. Okay, let's try and send some tokens to there. so this one was send or deposit multi-smooth. Okay. And this one, we're going to change these guys around. And we're going to get, not going to send value this time. And this time we're going to send an ESDT token. So let's see, I think we have this. Let's go to our Elrond converter real quick. Let's see, hex. Convert string to convert hexadecimal string. Okay, so F25 BB3. Okay, and we're going to send this token right here. Okay, to the smart contract. Alright, so let's give it a go. And this will be probably a value, I'm thinking. String the hex to decimal. Yeah, so we're sending, I think, 1,000,000. And what is this? Nope. And we're depositing, so we're passing a deposit command. So this is pretty much the same data architecture for the smart contract to interact with it that we played around when passing arguments in ERDPy. We're just kind of playing around and putting it inside here. So all the values look set. Compiled, so let's try this out. Now I haven't quite figured out how to update that to reflect the actual token, but you know, maybe that can be an assignment for if you want to play around. Now you can see I'm sending 1,000,000. Again, it's looking like it's found the dang token, the dong. And you can see the info we're passing in. So let's sign that. And while that's processing, let's see if we send that. And you can see there we did something. We go to the smart contract. Deposited the dong token, so they should have a good set of dong inside there. Very cool. Fantastic. So far we're interacting and sending different types of ESD tokens to them. So what I'm going to do is just copy this again. Make this 02 index deposit ESDT to smart contract. Okay. Fabulous. So now, let's see. So now let's try and find those notes to send. Let's send some EGLD back to my address, and let's see if we can vote on it. All through using the dApp dashboard here. Let's see. Okay. So I think what we we have to do is edit this. We are now going to send anything, but now, just like how we use DRDPy, we're going to do this. Propose the async call, and then saying that we're sending to this address, and the token name, everything of that nature. Okay. And instead of Pong, actually, let's see. Let's see. What did we propose them to send? That's an address. I know that, right? Yep. So that should be our address. SX50M. SX50M, yeah. Okay. So what is this? Okay, so we're passing ESDT transfer. And we're sending back a dong. So actually, we sent them this, so I'm going to update the code to send them that. And this is probably the value. Yep, still the same value. Okay. And we are sending... Similarly, we could dissect a lot of the ERDPy commands, like sending the EGLD back as well, so we can do that after this one. See, unable to ping, pong, here, pose send ESDT dong. This is so long-winded. Alright, let's see if this works. There it is. So let's do that. See all that gibberish. Notice this Pong's right here too. There we are. Okay. So now you had that propose async call going to the smart contract. Very cool. Remember, we have to sign off on this, so we have to get the queue here. And it looks like it's the first vote that we're doing for this. Cool. Now, as time goes, you can probably configure this where each button is performing something, but I'm just kind of showing you and dissecting through in this layman's method here. So I do appreciate you bearing with me, and, you know, for the sake and time of the video, that's why I'm kind of just doing it in this fashion here. Alright, so now that we have a thing here, just going to back this up again. Cool. So now, what we're going to do is sign the smart contract. And we notice that it was vote number 1, right? So, let's see. Setting all that, index. Okay. Here we are. And it was vote number 1. We're signing it, right? And instead of this long gibberish, okay, see. Now we have that. We'll make our way back to here, sign, approve, vote. Now since I deployed it, or Adam deployed it, we're going to have to log off here. Interesting, okay. It's kind of glitchy. I think it's just the, gonna have to do that micro app thing. No, that's not what I want. Nope. Let's go ahead and let's see. It should be all the same. So Patty and George. All right. And we're signing. Sign 1. Awesome. So if we look back at the smart contract, we have a signature come in. And let's now use George as a method here. The other approver. Okay. Another signature. Okay. All right. So now we have our 2 signatures. Excellent. So we'll take a look at our code again. So, just gonna copy this. Okay. Now, as time goes on and if you're just, fantastic at coding, you could probably figure out a way to create a, concatenate this here, add it to the end, and just make this be a variable where it pulls in the queue number of the vote into here, so it automatically updates and populates. You may even be able to fudge around and figure out how to query to see what votes are being posted to. But again, this is just a very rudimentary video, just to kind of get everybody on their feet. So, but you can, just giving you some ideas there. Okay, so now what we're going to do is let's just make sure everything looks good. Don't change anything. Okay. So now I'm going to say to perform action. And now I'm going to change this to the, you guessed it, perform action variable. Perform action, and we're performing action on the queued up number 1 vote that went by. And since George is a part of it, there it is, he should be able to also send the command to execute or perform action of what we voted on. George. Perform action. Okay. And there we are. So we performed the action, the vote got approved, and it's transferring the dog back into the wallet of Adam. So if we go to ESD, yep, looks empty. Go into the wallet. You'll see he got his dog back. Alright. Fantastic. So, yeah, for the heck of it, let's say that we try to send the EGLD back to Adam as well. Zero out this smart contract, right? So let's see. See, I'm trying to look through my notes here. I don't remember everything off the top of my head, as you may or may not know. It's not a savant. Or maybe we can look at the smart contract too. Let's see. That's this one. And we have a multisig. Let's see. Multisig. Multisig demo. Let's see. Deposit EGLD, but we want to send. External wallet 2 there. I think this might be it. Alright, so I'm doing this completely impromptu, so let's see if we can, do this, huh? Before I do that, let's just, copy this, paste that. Okay. All right. So let's see. I'll just go like that. Okay. And we're just going to reverse engineer all this stuff. Let's see. Probably just async call. That ESDT. Just gonna borrow some of this right here. Have it there. So we got our address. Okay. And then we should have, let's see, let's maybe send them 3. Or no, let's see if we can do all 6, huh? Mm-hmm. Let's see if this works. See if we get a value. Okay. Then and I think we also have to do, oops, this at 0, 1, at 0, 1. Okay. Now the Pong will outperform actually. There. Pose. EGLD. Back to add-on. Okay. George was the one that did it this time. Propose transfer execute. Let's see if this takes. Okay. So we have a proposal. And I'm assuming it's just going to be the second place here. Yep, second one, right? Okay. Excellent. So now we go through the rigmarole of doing it again. Let's see if this works, though. Okay, actually. So we propose, right? So now we can just, let's see, approval sign. Right, so we can just actually go like this. Paste it into here. Sign approve, vote. And it's the second one, so we're just going to do this. Sign and approve. Again, I think we're doing this out of George, right? Oh, you know what? He submitted the request, so I think we have to log out and log in as another individual. Let's go ahead and try Candy this time. Sign 2, looking good. And there we are. Alright. I'm going to close out of this one and look at the smart contract real quick. Got a signature. Got a signature from Candy. Yeah, this is probably that micro app thing. Probably would help with all of this, huh? Well, hey, maybe you know. If you do, leave a comment down below so everybody else will know, including you can inform me and teach me as well. Of all this, to repair this cache. It appears to be a cache issue. Let's do Adam again. And we are going to assign and approve. Mm-hmm. Okay. I got a second signature. So far, we are looking good. Alright, so I'm just going to back this up again. This was our 7th step. Let's see. Okay. Now we're going to perform action. Let's see here. Perform action, but this time we have to update it to be number 2. Perform action, so now we try. Doesn't look like that was the one, huh? Hmm. guess I grabbed the wrong snippet of code. Sub equal. Could just be missing something here. So we're proposing a smart contract or multisig. We send the proposed transfer execute, which we did. And did we get any transactions or anything? You don't see any deposits coming in here. So let's see here. I sent the perform action command, right? So let's see. Perform action. Said it was okay. List. Oh, dang. Propose to send EGLD. There, propose transfer execute, right? There's our wallet. And maybe we just need to add a value there? At this point, you're going for a ride with me. Very interesting. Well, let's see if this works. So, can just, let's do this. got rid of one of the empty things right there. Alright. Cool, so I proposed. Right. So approval sign. Oh wait, did I? Yeah, I proposed it, sign, and then perform, right? Alright, so we're proposed, now we're signing. Changing this to the third vote. Patty. Sign and approve. Okay. And we'll just make Candy do it this time. Candy. Boom. Boom. Okay. Okay. Now, let's see. See if this works. action. Sign, and then perform. Oh, there we go. So I guess I had that padding of the 0 there that messed things up. I guess the variable format didn't like it, so. Fantastic. Well, we see there's 0, so let's check our wallet. And there it is. Fantastic. So that is the working snippet of code that got rid of that extra at for that padding. Signed it. So I got the signature. Sign 2. And this one's a little different though because we did 3, right? Because we kind of had to go through it again. Might just decide to change that just in case you guys just do that. Approval, sign, actually, so let's just do this. Actually, it's perform action, right? Just cleaning this up for housekeeping so that way you guys are following. 2. Perform action. Doesn't work. Actually, you know what? I'll just keep it consistent. So that way when you guys follow it, and I'll just change this to be 2, just to keep it consistent when you guys try it on your end. 0, 2, form action 2, propose equals fixed. Awesome. So there you have it. We pretty much walked through and kind of showed how to interact using the dApp example to interact with the Multisig Smart Contract. So you take this information and you can pretty much use it for what you will. And you know what? If you, the community, has a good idea to take what I've shown here and show how you implement it in your own flavor, that'll be amazing. Maybe as an assignment, try to break it down, put some additional buttons, each one performing additional actions. That'll be great. And share your code, you know, let the rest of the community be able to see what you've done. And we can all learn from each other and hopefully increase our knowledge and help everyone else, you know, gain adoption for this project and this blockchain. So that will conclude everything for this video. If you have any comments, suggestions, questions, please leave it in the comment area down below. And don't forget to like, subscribe, and hit the notification bell. Alright, everyone. Talk to you later. Bye-bye.